Alrighty, this is take two now of water properties. This is just not going well tonight. It took me over an hour to upload a bad video. So here we go. Water properties part two. I'm going to know water so well. I will be able to, between these two, I'm going to be able to say them in my sleep. All right, here we go. Life as we know it, life and water. So, 2/3 of the earth is covered by water, and we, living organisms, are between 70 and 95%, depending on the organism. 70 to 90% of the entire body is made up of water. It's a very important subject. Very unique. So organisms are mostly water. Even Andre Agassi, after he is sweating, he looks pretty rough there. I don't think I would have used a different picture. All right, so remember we talked about water being polar covalent. So the covalent bonds, that's the sharing of the electrons, and polar because of the charges. So it's got partial negative for the oxygen and partial positive for the water. Now, this hydrogen bonding occurs between the water molecules. So you can see there's four different methods of bonding. So one of them is through the oxygen, hydrogen here of this. So here's our central water, and there's four different bonds coming up. So one of them is a hydrogen bond between the hydrogen of this water and the oxygen of this. The oxygen of this water molecule and the hydrogen, the oxygen and this hydrogen of this water molecule, and the other hydrogen and that oxygen. So four different bonds that it will make. Oxygen having this slightly negative charge, and it's more electronegative because it has this stronger hold on the electrons because it's got 8 positive protons, so it's got a stronger hold than the hydrogen. Has a slightly negative charge, but it has less of a hold because it's only got 1 proton, and so not as strong of a bond. And so lots of different things that can happen because of this hydrogen bond. It also helps, that hydrogen bond also helps water to conduct electricity very electricity, which is why we don't plug things in or unplug them when we have wet hands. We don't touch electricity because those electrons are going to transfer very easily through water. They're going to be conducted through water. All right, so now we have these different concepts. Have you ever wondered how water gets to the top of the tips of the leaves when it's coming in through the roots? It's not coming in through the leaves, it's coming in through the roots. It's got to go all the way up those big giant trees. So one of the properties is through what's called cohesion. And so cohesion, think of that word co again, that means together. So in cohesion, the water molecules bond with each other. So water to water, just like in this picture, this is cohesion. So cohesion helps get water all the way up in here. So those water molecules are sticking to each other. Now, they can't make it on their own just through cohesion. There has to be another concept, and that's adhesion. Adhesion is the water molecules sticking to something else. They adhere to something else. Think of a bandage, which is a Band-Aid, which is an adhesive Band-Aid. If the Band-Aid stuck to itself, it's not going to do any good. But what's it stick to? It sticks to your skin. And so it adheres to something different other than itself. And so in adhesion, the water molecules will stick to the sides of something. And so, excuse me, when we looked at a meniscus, when we looked at a graduated cylinder, and you can read that meniscus on there, the reason why it forms that U is because that water is sticking to the sides of the graduated cylinder. So it's sticking to itself and to the side. So between that, we have what's called capillary action, and it causes the water to be able to go up to the tips of the leaves. All right, so in this case, you can see these water molecules are binding to the sodium or the chloride ion. So they're binding to sodium and to the chlorine. All right, surface tension is another very important quality of water. So we have cohesion and adhesion. Because of that, because of these hydrogen bonds, the linking of the water molecules together causes this skin-like on the top of water. Now, it's not really a skin, it's just those water molecules are so linked together that it causes this surface tension, which allows an insect like the water strider to be able to skim over the top. Now, of course, it has, the physics of how its body mass is spread out, evenly distributed, helps by certainly, but if we didn't have surface tension, that wouldn't happen anyway. All right, so we're looking at the Earth and its temperature, the effect on water helps with the thermal regulation. Thermal means heat, so we're talking about the regulation of the heat on the Earth. So water is the only substance on Earth to be found in all three states: solid, liquid, and gas. So obviously we find gas in the clouds and gas evaporating here. We have it liquid water. Oh, the beach. Oh, wouldn't that be just fabulous? I think we need to take a field trip to the beach. And then, of course, solid in the polar ice caps and glaciers and things like that. All right, so water can act as like a huge piggy bank and a heat piggy bank. And when the sunlight hits the ocean and other water bodies, and the water heats up slowly as it absorbs the light energy. So that water warms up because it's absorbing that light energy. And it takes a huge amount of energy, lots of energy here, to break these. Remember, we have these 4 bonds here. So it takes a lot of energy for those to break at the same time. So those have to break in order for water to evaporate. So this has to break off, and then those water molecules go free. All right, does that make sense? So this is in its liquid state, and it's going to break free. So it takes a lot of energy in order to do that. Obviously, the energy from sunlight is certainly a way to do that. All right, so when we're talking about heat, we're talking about the total amount of kinetic energy. And remember what we said, kinetic energy is the energy of movement. It's in motion. And so the total amount in a substance, that's what heat is, the amount of the kinetic energy. So there's so much energy moving through this metal right here, it makes it glow. All right, so temperature, the intensity of all, is the intensity of all the heat in a substance, where heat was the amount of kinetic energy. Now temperature is the intensity of that heat. All right, so ice versus water. It's all about molecule movement, okay? So obviously gas, that water molecules are moving very quickly, and they're moving around very rapidly because those hydrogen bonds have been broken. Liquid water, you can see these bonds, but you'll notice those bonds are a little larger here. The length is a little larger than here in ice. Have you ever wondered why ice floats? I mean, clearly, ice is a solid, so it should sink. A rock doesn't sit at the top of the water. And so why does ice float? I mean, it's less dense, but why? I mean, we're talking about the molecules should be closer together, right? As things cool, those molecules get closer together, yet in ice, it floats. Well, because ice has this really cool property, or should I say water has this really cool property, that right before liquid water turns to ice, it condenses down, and then it's condensing down, and then right before it freezes, water expands. Those molecules expand. Those bonds expand. Now this is real important for us, because if it didn't do that, then ice would not float. All right. Now, there's a concept of evaporative cooling. Water on the surface. So clearly Andre Agassi here is sweating. He's got water that comes to we have water that comes to the surface of our skin, and as that water evaporates, it cools. It pulls the heat away from us. And so that's why when wind is blowing and you're sweaty, it feels great because it's pulling that water, that heat away from us even faster. All right, so evaporative cooling. Now, the other thing with evaporative cooling is when we're talking about humidity, and humidity is water vapor that's in the air. This decreases the effect of water evaporating because there's already so much water in the air. The new water that's trying to evaporate has nowhere to go. It's kind of like when we were talking about saturation. If whatever's trying to soak up water is already almost saturated, there's very little it can soak up. All right, so back to water, and it's freezing. So these molecules will expand. So right here, not the molecules, but the bond will expand right before it freezes. This makes water less dense, and it floats. This is real important because if ice didn't float, then as it froze, it would sink to the bottom. It would crush everything below it and not allow anything to survive. And so we have to have water that floats on the surface. We call water the magical. It's got magical properties. It's magic. And what else is magic? Is this video is done. That's magic. Have a great night. Thanks for tuning in.